Good morning, guys. Today, inshallah, we're going to continue what we started yesterday. Today, inshallah, we're going to keep talking about the Newton's law of motion. And we said Newton state three laws that describe the effect of force on a motion or describe the force that's applied on an object. So we already done by the first two laws. Okay, the first law state that the static object keeps static and the object in motion keep in motion or keep in the motion with the same velocity and direction until it affected by unbalanced force. And the second law states that the acceleration of a moving object in motion depends on the mass and the force of applied on this object. Today, inshallah, we talk about the third law of motion. Actually, this law is very, very important. So what it does it say? Okay, here this one. So he said that whenever one object exerts a force on a second object, the second object exerts an equal and the opposite force on the first. What does it mean? That means when you apply force on an object, this object will apply the force or will apply force equal in magnitude, equal in amount, but actually in opposite direction because the object will apply this force in your body. Actually, that's somehow it's hard. So what does that mean? Something tricky. So let's find here. We could simplify the idea or the third law that all forces act in pairs. What mean by all forces act in pairs? So let's find that together here, guys. For example, if we said, okay, that we have a chair, okay, so you got a chair, for example, like that, and you're gonna sit on that chair, okay? So while you're sitting on the chair like this, what happens? You apply a force on the chair that represented your weight. It's considered a force that you apply on the chair. In the same time, or we find that the chair apply force in the opposite direction, okay? This force equals to the body weight because actually if there is no force in the opposite direction and just your force only, so you will break the chair and you will fall down, and of course that doesn't happen, okay? So here we find that any action has a reaction. That means any force is applied have a force in the opposite direction, okay? And we find these two forces somehow they have the equal amount or they are equal in the magnitude. So here there is a very, very important point to clarify that the two forces have the same amount and they are in the opposite direction. So that means the net force equals zero. No, net force doesn't equal zero because if always the net force equals zero, so no object will move or no object will be in motion ever. So how you said that they are equal in magnitude but different? Yes, but they acting in two opposite objects. It means, for example, here you already apply about 10 Newton. They already done on the chair. So 10 Newton applied on chair while the chair applied 10 Newton also, but in your body. So they are equal, okay? They are equal in amount, opposite in direction, but in two different objects. So here, like this is, I can't calculate the net force in this case, okay? Or I can't because they already two separate objects, so I can't even subtract them or subtract them because they are two different objects, guys. So this is very, very important here. So we could observe this a lot in our daily life. In some cases, okay, we could find that any action you have a kind of reaction. Like for example, as you said, the chair. When you drop a ball, okay, on the ground, so the ball start to bounce because once the ball hit the ground, it's already pulled because of the gravity of the earth. In the same time, okay, the force is applied once they hit the ground. Some force is applied to the surface on the pole, so they start to bounce like this. So any action has a reaction, or any force, okay, has an opposite force or has a force in opposite direction that equal in amount. So here we said, so the force work in pair but do not act on the same object. So a force is always exerted by one object on another object. This rule is true for all forces, including action and reaction forces, okay? That means action and reaction forces in a pair do not act on the same object, because if they act on the same object and we said they are two opposite forces with the same amount, so the net force will be zero, and like this no object will move, and of course doesn't happen. So here we have two different objects, each one perform the same force on the other object in two opposite directions. So here we said that the third law of motion, all forces act in pair, as we said, so we call it action and reaction. So simply we could rephrase the state or rephrase the third law, and we say that any action has a reaction equal in magnitude and in opposite direction. Okay, so like this we could simplify the law of Newton, or the third law of Newton. The problem here, guys, or the problem regarding to this law, that sometimes it's hardly to observe the reaction. Always we observe the action, whatever do, or the force we apply, or the observe, or we observe the force which is applied. But always the reaction of object is not that clearly, is not obvious for our eyes. So sometimes it's hardly to believe that there is a reaction. For example, when you fall, just make something fall down toward the gravity, this object is already attracted because of the gravity force. But also this object has a kind of gravity because it has a mass, and we said that whatever anything has a mass, it also has gravity. That means it already pulls the force back. But regarding to the huge difference of the masses between the earth and the pole, we can't observe this. What does it mean? Let's see together. Here we said, for example, here, guys, so that's, for example, the earth, okay, and we are gonna just let a pole fall down. So this pole, once it falls down, it's already attracted to the earth because of the gravitational force. Okay, so that's the force of gravity. Okay, so actually you observe this clearly, but actually in the same time this pole has a mass, and as it has a mass, it also has a kind of gravity. So the gravity of the ball, so we could call it gravity of the ball. This gravity of the ball, it attracts the earth toward it. Okay, but of course, because the mass of the ball is too small compared to the mass of the earth, so we could find that the only thing that could observe is the action. That means the effect of the gravity on the ball, but we can't find, or we can't see the effect of gravity ball on the earth because the earth is too huge. So in this case, it's clearly, or the what is observed is the action, but the reaction is hardly to be observed, although they have the same force. But imagine here the earth is pulling, okay, for example, the ball with 10 Newton. So 10 Newton once applied on this small mass of the ball, it's easier make the ball moves. While when the ball attracts the earth with 10 Newton, the same amount in the opposite direction, of course 10 Newton, once they applied in this huge earth, of course it will not affect it on our obvious scale, or whatever that we could observe with our naked eye. So here that's the problem, that sometimes it's hardly to observe the reaction, so we don't believe it's found, but actually it is found. Because imagine if there is no reaction, so suppose and just one force applied on this, or the force on the ball, so that means the ball will keep moving forever, and it's actually will not, that can't happen, guys. So here that's the idea, or that's the third law of Newton. So like this we have three laws that describe the motion. Okay, all of them they talking about the effect of the force on the object, or how the object moves. That's the end of our lesson. Thank you, guys. Goodbye.